the destruction of the Imperial Japanese Navy battleship Yamato on April 7, 1945, initiated one of the most violent structural failures in maritime history. Displacing over 71,000 tons fully loaded, the vessel represented the absolute peak of armored warship design. She was underway on a one-way surface mission to contest the Allied invasion of Okinawa, but her demise was not a matter of simply being battered to pieces by aerial bombardment. Her loss was driven by an escalating buoyancy failure that turned immense displacement into a liability. The strike force of United States Navy carrier aviation targeted the ship with successive waves of torpedo bombers and dive bombers, triggering a catastrophe that would ultimately claim the lives of over 3,000 personnel. The technical failure was asymmetric flooding. A warship of this scale relies on an intricate grid of internal watertight compartments to manage combat damage. When the hull is breached below the waterline, water ingress is designed to be countered by intentionally flooding opposing compartments on the other side of the ship to keep the deck level. On that April afternoon, the ship absorbed overwhelming damage that was heavily concentrated on her port side. Multiple aerial torpedoes ruptured the underwater protection system and opened paths for flooding through the port side, allowing thousands of tons of seawater to rush into voids, boiler rooms, and engineering spaces. The damage control teams attempted to restore equilibrium by flooding the starboard compartments, but the sheer volume of seawater entering the port side quickly exceeded the total mathematical capacity of the counter-flooding systems. As the list deepened, the physical geometry of the hull began to work against the ship. The center of gravity shifted irreversibly outward toward the port side. A list of 5 degrees became 10 and then 15. As the angle worsened, the low side of the hull settled deeper into the sea. Openings that were never meant to be submerged were driven closer to the waterline, and each new compartment lost to flooding made the next correction harder. Once the hull lost balance, the armor scheme designed to survive heavy gunfire became part of the capsize mechanism. The uncorrectable list to port steepened until the main deck edge submerged and the vessel rolled completely onto her side. As the ship inverted, the final and most devastating phase of the loss mechanism occurred. With the massive structure tearing itself apart under the stress of capsize, an immense internal explosion erupted from the forward part of the ship. The blast is widely associated with the main magazines, but public evidence cannot confirm the exact ignition path. It generated a towering mushroom cloud visible for miles, tearing thousands of tons of forged steel apart in a fraction of a second. The supersonic pressure waves shattered the central structure of the vessel. The largest battleship ever constructed did not just sink in combat. She was obliterated from the inside out, dropping completely out of sight and plunging deep into the dark waters of the East China Sea. What remained on the seafloor after the mushroom cloud cleared and the debris settled? Roughly 1,130 feet below the surface of the East China Sea lies a wreck site treated with exceptional restraint. The shattered remnants of the vessel rest in a tightly controlled deep water environment protected by sovereignty, war-grave sensitivity, and the practical limits of access. As an internationally recognized sovereign war grave containing the remains of over 3,000 personnel, the site cannot be treated as abandoned material for private recovery. Any intrusive work, artifact removal, or salvage would require formal authorization from the state, with sovereign rights over the vessel. The legal boundary is therefore severe, even if it is better understood as controlled permission rather than automatic physical impossibility. Operational risk adds a second layer of caution, with immediate physical consequences for any deep survey. Over the decades, the waters above and around the site have been exposed to ordinary maritime activity, so any deep survey must assume snag hazards, loose lines, sharp steel, and currents capable of trapping or damaging an investigating machine. A remote-operated vehicle cannot simply descend as if the wreck were a clean museum exhibit. Compounding the operational caution is the possibility of ammunition, propellant residues, and hazardous military material remaining within the wreck field. Yamato carried 46-centimeter main guns and specialized anti-aircraft shells known as sanshiki, along with secondary weapons and large quantities of ammunition. But the exact condition, distribution, and sensitivity of any surviving ordnance cannot be asserted from public survey evidence alone. That uncertainty makes even incidental contact an unacceptable operational assumption. Because physical clearing and debris removal are legally and operationally barred, specific historical debates cannot be resolved through direct metallurgical sampling. A profound limit remains in the historical record. American aircrews reported numerous apparent torpedo strikes during the final battle, while wartime claims did not always separate confirmed hits from near misses, overlapping attacks, or duplicate observations. Later summaries commonly place the damage at roughly 11 torpedo hits and about 6 bomb hits, though the port side pattern remains debated. Closing this discrepancy would normally require a destructive sequence, cutting into the lower hull, clearing the heavy overburden of mud, and counting the primary blast holes along the port side armor belt. But the sovereign boundary prohibits clearing operations, and the immense internal detonation atomized the area where the heaviest concentration of torpedoes struck, turning the impact zone into a chaotic mass of fused steel. Together, those limits mean that some parts of the forensic record are difficult and perhaps impossible to read from public survey data alone. The access boundary forces a methodological pivot. Instead of cutting, lifting, or penetrating the wreck, modern forensics must work through controlled observation. How can engineers map and investigate a shattered 71,000-ton ruin without physical contact? The survey objective was to build a visual and positional record for preservation, not recovery. Each controlled ROV pass had to return imagery, depth context, and camera position precise enough to support later reconstruction. Executing this method over a massive debris field required intense pilot discipline. Its survey passes had to cover the site with the discipline of an aerial grid over broken terrain. During these passes, the pilots constantly monitored sonar returns to detect the invisible commercial fishing nets suspended just outside the reach of the floodlights. The lighting arrays on the vehicle had to be precisely angled to cut through the particulate matter in the water column, known as marine snow, illuminating the dark shapes below without washing out the visual contrast. That contrast was essential because the later mapping process depended on overlapping optical passes to calculate the spatial geometry and depth of the wreckage. The process demanded over 50 hours of continuous high-definition video capture. Every flight path was essentially a low-altitude survey run executed in total darkness. If a sudden current pushed the vehicle off its designated track, the pilots had to break off, safely reset their position in the water column, and begin the pass again to ensure the photographic overlap was not broken. The precision of the flight lines was the only way to guarantee a complete scan. After capturing the necessary visual data, the heavy computational work began topside. The engineering team fed the vast database of still images into specialized photogrammetry software. This system searches for millions of common anchor points across the overlapping photographs, matching a specific jagged edge of torn armor plating in one frame to the exact same edge viewed from a slightly different angle in the next frame. By triangulating these match points, the software calculates the distance and elevation of structural elements, generates a dense point cloud, and surfaces it with high-resolution photographic textures, so researchers can virtually measure and inspect the wreckage down to the centimeter. By adhering to this disciplined, non-intrusive methodology, the expedition converted the site into hard engineering data without disturbing the wreck. As the overlapping frames resolved into a digital model, the first answer was not a detail, but a rupture. The digital grid revealed a mechanism of total structural failure written into the steel. The contiguous wreck does not lie on the seafloor as a single intact vessel. The mapping data confirmed that the main hull is violently severed into two completely separate primary sections, a break so abrupt that it points away from ocean pressure and toward a catastrophic event originating within the armored citadel itself. The forwardmost portion of the ship survived as an isolated structure, separated from the main wreckage and partly settled into the mud. This segment carries one of the most distinct visual signatures on the site, the Imperial chrysanthemum crest at the bow, recorded by later surveys as a powerful confirmation of identity. Its posture and the exact timing of its separation, however, must be described with caution rather than treated as absolute proof of a single sequence. A significant distance away from the bow lies the massive mid-to-stern section of the hull. Unlike the forward segment, this enormous length of continuous steel rests completely upside down, confirming that the fatal roll continued through its rotation as the vessel sank. The massive rudders and the four main propeller shafts point toward the surface. The continuous armored deck is buried under thousands of tons of steel and mud. Between this inverted aft section and the upright bow, the space where the forward superstructure, the bridge, and the forward heavy weapon mounts should be is absent, marking the blast zone rather than a readable section of continuous hull. The extreme bisection of the heaviest armored hull ever constructed is consistent with a catastrophic internal explosion in the forward ship, but the wreck record supports magnitude more securely than origin. The continuous hull evidence demonstrates the internal character and scale of the blast without needing to replay the explosion itself. The bow and stern remain as separated monuments to the bisection, but the geometry leaves one immediate question: where were the massive main batteries when the hull came apart? The off-hull debris field supplied the answer. The three heaviest components of the ship are absent from the primary wreckage zones. Resting inverted in the deep mud, completely isolated from the continuous hull segments, are the three main gun turrets, each a mass of concentrated armor, machinery, and gun weight. Their location is best explained by gravity detachment. In traditional heavy battleship architecture, primary turrets are seated by weight rather than bolted, welded, or clamped to the deck. The rotating armored housing, gun barrels, breeches, and machinery remain inside their cylindrical barbettes because gravity holds the assemblies down as they turn on roller bearings. Once the hull rolled past a fatal angle, that assumption reversed. The turrets slid out of their mountings and fell away from the capsizing ship, establishing a narrow but important conclusion. Yamato had rolled beyond any recoverable attitude. Beyond the three main turrets, the wider debris field is an expansive and chaotic scatter of detached evidence. A massive field of jagged armor plate, secondary weapon mounts, twisted bulkheads, and unexploded ordnance is distributed over a remarkably wide radius. This vast debris spread was not merely the signature of a ship settling gently to the bottom. It reflects the combined violence of capsize, internal explosion, structural breakup, descent through the water column, and impact with the seafloor. The detached evidence paints a picture of total, chaotic destruction surrounding the main structural remains, even though the exact path taken by every fragment remains beyond reconstruction. Yet, despite this comprehensive map of the wide debris spread, a permanent proof ceiling remains locked in the mud. Because the forward magazines themselves were completely obliterated by the detonation, the exact ignition source inside the ammunition handling rooms remains permanently hidden. The forensic timeline proves the turrets fell out, but it cannot show what sparked the propellant. Whether the deflagration was triggered by hundreds of heavy artillery shells violently shifting, colliding, and detonating as the ship inverted, or by an existing internal fire rapidly spreading into the exposed propellant, is a question that the detached evidence simply cannot answer. The blast erased the very mechanics of its own ignition, leaving only the scattered remnants as proof of its scale. With the hull fully mapped and the debris timeline proven, what remains for the future of the site? Traditional maritime exploration often views a successful mapping as the prelude to physical recovery. The discovery of a precise location and the generation of a comprehensive structural map typically trigger a phase of artifact extraction and metallurgical sampling. But for this specific wreck, the completion of the deep water survey triggered the exact opposite institutional response. The comprehensive understanding of the site reinforced the sovereign and commemorative boundary around the wreck. The choice was made to preserve the site in place rather than convert survey data into a program of recovery. The final management condition of the wreckage is therefore one of restraint, not extraction. The site remains locked not out of a lack of technical capability to lift debris, but due to an active, enforced administrative mandate. The 2016 expedition commissioned by the Cure Maritime Museum achieved its ultimate goal by translating the physical reality of the seafloor into a permanent digital state. The raw optical data captured during the highly controlled survey was synthesized into a detailed visual archive and interpretive record. This reconstruction and the released imagery allow researchers, historians, and the public to examine the structural remnants of the ship without disturbing the physical war grave. The museum established a stewardship model centered on documentation, exhibition, and preservation in place. The shattered steel, the scattered ordnance, and the entombed crew remain exactly as they fell, while the exact geometric footprint of the destruction is preserved indefinitely above the surface in digital memory. By accepting this purely digital outcome, the managing authorities also formally accepted the permanent limitations of the forensic record. The questions that remain unanswered will never be physically investigated. The precise count of incoming aerial torpedoes and the exact ignition source within the forward ammunition handling rooms remain unresolved in the public record. There is no indication that future research would justify dredging the mud, clearing heavy debris, or extracting sections of the armored belt simply to count impact craters. The stewardship protocol treats the pursuit of absolute historical certainty as secondary to respect for the sovereign war grave. The unproven elements of the disaster remain part of the wreck's historical shadow, rather than a mandate for physical excavation. The final legacy of the survey is one of extreme technical restraint. The engineering teams withdrew their remote-operated vehicles from the dark waters. The mapping algorithms finalized their calculations, and the exclusion zone was left perfectly intact. Decades of commercial fishing nets will continue to drape over the torn bulkheads, and the deep ocean currents will slowly corrode the heavy armor plating. The site is preserved in place and approached only through authorized non-recovery survey, protected by a legal and commemorative shield that refuses to turn the wreck into a salvage prize. The largest battleship ever constructed rests at the bottom of the East China Sea, defined now not only by the violence of its destruction, but by the disciplined, deliberate institutional choice to let the physical war grave remain in the dark.